Hey guys, this is Mr. Grice for Algebra Unit 7.4 Notes. Today we're talking about factoring polynomials by using the greatest common factor. Our learning target today is to be able to factor polynomials by using the GCF. And GCF stands for greatest common factor. Okay, so before we get started, this is just video 1. Okay, video 1's just going to cover the first page. Video 2 will cover the back page. Now, let's begin. Factors. A factor are numbers or variables that divide evenly into another. Okay, so a number or a variable that can divide evenly into another. Okay, we'll be like, what are you talking about? Well, let's think about this. What are the factors of 20? What numbers multiply to get to 20? Well, 1 times 20. That equals 20, right? What about 2? 2 times what? 2 times 10 gives us 20. See how those are evenly going into it? 3 times, 3 times what gives you 20? It's not even, I don't even know. Okay, so, nope, that doesn't go evenly. What about 4? Well, yeah, 4 times 5 gives you 20. Okay, so that's what we're talking about evenly. And you might be like, is there a faster way to do this? Well, yeah, it's called a multiplication chart. Do you have a multiplication chart? Yeah, you do. Look, I'm at the website. See what my guy's pointing at right here? Multiplication chart. You can click right here and boom! Multiplication chart. Okay? So all you're doing is you're trying to find 20. So there's 1 and 20, 2 and 10, and when you come across 3, see how it doesn't go in evenly, so it's not 1. So then we got 4 and 5, and that's how we get to 20. Okay? Now, if you don't know your times tables chart, we highly recommend that you get a times table. Okay, we've got small copies of them that you can pick up from Ms. Carranza or myself. So, when we're asking you to list the factors of each monomial, this is how we're going to want you to do it. Okay, 70. So we're always going to start with the number. And now we're going to list all the factors. So what numbers multiply to get to 70? It's always going to be 1 and the number. Okay? Now, if you have your multiplication chart, you can just kind of go and look. But in this case, we don't have it. So another way to do this, you can just go 70 divided by 2. And we get 35. So we got 2 and 35. Now, does 3 go into 75? It sure does. Or not, we're looking for 70, Mr. Grice, not 75. But if you see 6972, how it doesn't work, if you just go on your calculator, oh, decimal, doesn't work. What about 4? Doesn't work. What about 5? Yeah, 5 and 14. And that's where you can look on here and find it as well. Okay? So we get 5 and 14. And then the 7 and 10. And you can be like, oh, Mr. Grice, do I have to keep going? Well, let's find out. So we did 7. What about 8? Nope. What about 9? Nope. What about 10? Hey, 10 works. And if you notice, we already have 10. So once you find a number that repeats, you're done. You don't have to do it again. Okay? So let's try 36. So the multiples of 36, or the factors of 36 are always 1 and the number. What about 2? Yep, 2 and 18. 3 and, should get 3 and 12. 4 and 9, and then 6 and 6. Okay? And you can either do that by just going, well, there's 36, there's 36, there's 36, and there's 36. And we know we're done because we've got 6 and 6. It's the same number, so that's where we're starting to repeat. Okay? Now, for questions like 3 and 4, list the factors. Well, what do you multiply to get to x squared? And this is where all you have to do is count the variables. How many variables are there? There's one, Mr. No, there's not one. There's two. Okay? This x squared really means x times x. And 4, how many m's are there? There's 2. M times m times 4 n's. 1, 2, 3, 4. And so that's all they're asking you to do there. Okay? All right. Hopefully that wasn't too fast. If you have questions on that, make sure to come see us. Now, greatest common factor. Greatest, the GCF of 2 or more numbers is the largest number that divides evenly into all of the numbers. Now, some of you might be able to look at this in 1242, boom, I know what it is. It's 17. Well, first off, it's not 17. But you might know that right off the back of your head, and that's fine. Okay, if you don't though, we have to show the work. And the way we do that is just by writing the list of the factors of the numbers. Okay, so the factors of 12, well, we said it's always 1 and the number. How many times does 2 go into 12? Well, 6. What about 3? Well, 3 times 4, and then 4 and 3, so we start repeating. Now, 42. We have 1 and 42. What about 2? Use your multiplication chart or use your calculator by dividing. It's 2 and 21, 3 and 14, and 6 and 7. So I want the highest number, the biggest number that are on both lists. Is 42 on both? 21? Nope. 14? Nope. 7? Nope. 6? Is 6 on there? Yeah, see how 6 is on both lists? That means that our GCF, you would write it just like this, that the GCF is 6. That's what we're looking for. Okay? Now, for number 6, they want 3 different numbers, which means we have to do this 3 different times for 15, 30, and 60. Okay? Why don't you guys see if you can get all the factors? Pause the video, and then we'll catch up in a sec. Okay, so there's all of the numbers. And now I would always start with the biggest numbers to see if they're on all of your lists. 60? Nope. 30. No, 30's not on the last one. 20? Nope. 15? Yeah, 15. See, it's got to be on all 3 of them. Okay. So the GCF is 15. All right. So now this next part is saying the GCF of 2 or more variable expressions is the largest amount of each variable that can be taken out of all the expressions. Okay? You're like, Mr. Grice, that makes no sense at all. Okay, well, let's take a look. Here's an example. What is the largest amount of x's that I can take out of those two? So let's take a look. All I'm looking at are the x's. Okay, and if we need to write it out that this is x times x times x, we're writing it out the long way. Woo. What's the most amount of x's that I can take out? Well, I can take out 3. See how both have 3? So the most we can take out is 3. Now, what happens if I were to change that and say y's? What's the most amount of y's that we can take out? Well, let's see, this one only has 2 and this one is 5, but it's got to be the same. So the most I can take out is y squared. Okay? So the trick to this, the little shortcut, is you look for the smallest exponent of each variable. Well, the smallest exponent was 2, and that's why it's 2. For the x's, they both had 3, and that's why it's 3. Okay? So let's look at the notes. So find the GCF of w squared and y and w cubed times m. Well, let's take a look. Which variable do they both have? Well, they both have w's, right? Which one's smaller? The 2. So my GCF is w squared. Okay, and if you need to write it out the other way, y times w, there's that guy. And then let's write this one, w times w times w times m. The only thing they both have in common are 2 w's, and that's how we get w squared. Okay. Oops. All right, let's look at the next one. So the next one, we have 3 terms. So let's try to find the GCF. Now, looking at those 3 terms, let's look at the m first. What is the smallest variable? Or the smallest exponent for the m's? It's m to the first, right? So I can only take out 1m. Now let's look at the n's. Which one is the smallest? Well, the smallest is n squared. Okay, and the point is I can't take out exponents if they're not there. We can't take out more than all of them have. Okay, all right. Now, the next part says to find the GCF of the following monomials. So now, not only do we have the numbers, but we also have the x's and the variables, okay? So, if you need to, let's draw out the factors. Okay, the factors of 28 are 1 times 28, 2 and 14, and then 4 and 7. Okay, the factors of 35 are 1 times 35 and 5 times 7. So what's the highest number they both have in common? Okay, it's 7. Okay, but now our GCF isn't just 7. What about the variables? We have to look at, okay, what variables do they both have in common? And then how many? What's the smallest of those exponents? And it's 6. So our GCF is 7x to the 6th. Okay, let's try the next one. So we have to start with 24, listing all the factors, and then 36, all the factors. 1 and 24, 2 and 12, 3 and 8, 4 and 6. Okay, 36 is 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. So what is the greatest, not just a factor, be like, oh, they both have 2. Correct, but that's not the greatest common factor. Okay, the greatest common factor is 12. Okay, but now we also have to look at the variables. Okay, x squared and x, the smallest variable is the x, and then y and y cubed, the smallest is y. Okay, so our greatest common factor, our GCF, is 12xy. Okay, and then 11. So remember, we start off by writing the factors. Well, the factors of 17 are just 1 and 17. 19 is just 1 and 9, so our GCF is 1. Okay, and now let's look at the variables. C4 and C2, so the smallest is the 2. And then now look at your D's. D5 and D8, the smaller of the 2 is D5. Okay. All right. Well, guess what? That's just the warm up. Okay. So in order to do the next page, you really need to understand this page. Okay. So if you need assistance, make sure to come see Miss Carranza or myself. All right. So this is the end of video 1. Remember to make sure to watch video number 2. Thanks, guys.